Hello everyone, a warm welcome to each one of you. Today we are going to observe how expressions are simplified using different properties that we have understood in yesterday's session. Let's explore together. Before just diving into this session, let's just warm up with some questions. Are you ready? Can adding two irrational numbers give a rational result? I just want you to answer this question. What do you feel about this statement? Can it be always right while adding irrational numbers will give you rational result or always irrational result? What do you think about that? Just try to write one or two examples just to justify your answer. I'm sure you have found your way. Let's just take this example. Under root 5 plus under root 5 be irrational or simplified. Will it be irrational only? Or will it be giving you a rational number? What do you feel about that? Here is the case. Under root 5 plus under root 5 will always be irrational. Irrational adding up to irrational mostly give you irrational. But always? No, ma'am, not always. Here, see this example. Under root 7 minus under root 7. Let's suppose we are adding them with opposite signs. Under root 7 plus minus under root 7. Basically, you are adding the opposite of under root 7s. Will it be rational? Think over it. What are you getting as answer? 0, and 0 is your rational number. So adding up irrational numbers not always give you irrational results. What are today's learning objectives? We will understand how these real numbers, irrational numbers, rational numbers behave under operations. We'll solve some examples using the identities. We'll just brainstorm yesterday's topic by solving some examples. Are you ready? So let me just ask you one question again. Under root 5 plus under root 5. Is it rational or irrational? Even I have just told you the answer. How you are going to apply this strategy just to write your answer, just to justify your answer. Think of it like that. Let's suppose you are adding one apple to the another apple. One apple plus one apple. One apple plus one apple. Your answer is two apples. It's obvious. But you didn't add two apples literally. You just counted how many of the same things you had. So basically, under root 5, 1 under root 5 and second under root 5 will give you the answer as 2 of under root 5. Here, 2 apples are you getting? You didn't add apples literally. You just counted how many of the same things you have now. So, same things are there. Like terms are there. How many like terms are there? 2 like terms are there. So, what would be your answer? Your answer would be 2 of under root 5. Like 2 of apples, here 2 of under root 5. That would be your irrational number. It cannot be solved further. Under root 5 is non-terminating without any pattern. So getting it doubled will give you the irrational result again. Shall I move ahead? What is under root 7 minus under root 7? It's very obvious. It's very obvious. The answer is 0. That is your rational. So what is the result you got? Adding up to irrationals will not always give you the irrational quantity. Now find the product of under root 2 multiplied by under root 8. How are you going to multiply them? We just added under root 5 twice. I just take double of the same term under root 5. But here, how are you going to multiply them? I'm just making you write a property. Write a property along with me. When two under root quantities are getting multiplied, I can take the square root of them in a combined form. Yes, these can be multiplied and this under root can be taken as a combined form. Just note down this result, and by using this result, just solve this question. Under root 2 cross under root 8. What would be your answer? What would be your answer? Just take the under root in a combined form together. 2 multiplied by 8, that is your 16. And you know that 16 is a perfect square. Your answer is 4. Hence, it is a rational number. Yes, by multiplying two irrational quantities, you got one rational result. So what did you get again? Well, adding irrationals, well, multiplying irrationals, not necessarily you are going to get the irrational quantities. It may be irrational, it may be rational too. So are we on the same page? Written? Check whether the sum of under root 2 and under root 3 is a real number. What do you think about that? Under root 3 got added to under root 2. These are not like terms. These are different ones. When added up together, will the result be irrational? Think deeper. Well, yes, ma'am, the result will be irrational because I am adding two unsold, unpredictable quantities. And somehow here I'm getting again the unpredictable quantity. These cannot be solved further. So hence your result is irrational. Cases could be irrational ones, cases could be rational ones that we have done so far. But here is the case, irrational plus irrational. Here the example is giving you the result as irrational and hence it is a real number. Yes, real numbers are including all of the numbers present on the number line. It could be fractional, it could be rational, it could be irrational, it could be anything. Yes, real numbers are closed under addition. We know that real numbers are closed means what? They are following the closure property. Yes, think about the rational numbers. Two numbers are belonging to a same set. The result is also belonging to the same set. But in irrational quantities, you have seen that. Here, I have just taken the example under root 7 minus under root 7 means two irrational quantities getting subtracted, giving you rational ones. Those two quantities were belonging to a set that was your irrational, but the result is belonging to the different set that was your rational. That means irrational numbers are not always closed. Yes, under closure property you would say, but mostly real numbers are closed under addition. Here is the example. It's not a fact that it would always follow. The thing is, whatever we are taking the example, we have to justify our answer. Here the answer is justified by the statement, yes, real numbers are closed under addition. Yes, we have shown that when real numbers are not closed under addition, then we can justify our answer by giving another example. Got it? Now, which property is illustrated over here? Just observe the property. Remember the hint? It's a it's a game of brackets of three numbers. The numbers are same in either sides. Under root 3, under root 2, under root 5, under root 2, under root 3, under root 5. The numbers are same in either side. But it's a game of brackets only. Here the bracket is put under first two numbers. Here the bracket is put after last two numbers. Yes. So which property is it? Associative property we are talking about. Grouping property we are talking about. When brackets came, it's related to associativity. Yes. A, B, alphabetical order, associative, brackets. Associative property of addition was it? And which property is observed here? Which property is observed here? Just look here the example under root 2 cross under root 3, whatever the result is coming as, will it be equal to under root 3 cross under root 2? What do you think? What is happening over here? Here the order is getting flipped. Here the order is getting flipped. Just a matter of order. The property is, say it loud. The property is commutativity. Yes, commutative property of multiplication. Grouping property means associativity. Order property means commutativity. Yes, a commutative thing. Here, the question is popping again. Let's just simplify. Just simplify within 30 seconds. Under root 5. I'm so sorry, 5, not under root 5. I'm just used to these irrational numbers, under root 5, under root 2, under root 3. But here is the simple clean number 5. 5 is getting multiplied the numbers that are present under the bracket 2 plus under root 3. Remember the property. A number is getting multiplied across the terms present under the brackets. What is the property? What is the hint that I have taught you yesterday? It's a combination of two signs, either multiplication with addition, either multiplication with subtraction. How are you going to solve it? Have you solved it? 30 seconds are over. Are you waiting for me? Let's just do it. 5 will be multiplied by this 2. Also, this 5 will be multiplied by this under root 3. And this plus sign will be taken in between of them. Yes? 5 into 2 is your 10. 5 under root 3. How are these quantities be multiplied? Just take it together. These are not getting multiplied. These are not like terms. And one is rational, one is irrational. Just combine them like that. So this is the result, because after solving this result, you are going to get the irrational number. So no point solving it further. You can skip it. The answer is yours. 10 plus 5 under root 3, because under root 3's value is 1.73, keeps on going. You can either multiply it by 5, then you can add it up 10, but your 3 dots will be prominent over here. So no point. You can just keep it here only. So your answer is 10 plus 5 under root 3. Only the matter was just to simplify till you can. Done? Very good. My number explorers, you have got pro now. How are you going to solve this question? 3 cross 2, 3 plus 2 cross 4 plus 5. Either you can solve it simply. Ma'am, it's very easy. So easy thing. 3 plus 2 is 5. 4 plus 5 is 9. And your answer is 45. This is simplified very simply. But read out the heading. Simplify using distributive property, not simply, not according to Bort mass only. You have to use the distributive property. That was the concept here. Yes, you need to use the properties. So what are we going to do it? In the previous question, we were getting only one number present ahead of the bracket. Yes, but here two numbers are present ahead of the bracket. Just take one firstly, then take second firstly. How? Take just this 3. 4 plus 5. Then take this 2. 4 plus 5. Yes, split the first term, first bracket, first term along with the bracket, second term along with the bracket. Your answer is 45. Understood? Just note it down. Let me just make it more clean. Note it down. It's very easy. We need to just identify the property and you will get the answer. All set? Now let me just ask you one question again. You have to tell whether it is true, whether the statement is false. Distributive property can be applied only when all terms are rational. Is it so? When all terms are rational only, then the distributive property is applied. Think deeper. Some are saying yes, but it's not true. It's not true, it's false. Even we have done the example, previous one. That was containing the irrational numbers. So no, it applies to all real numbers, including irrationals. Yes. Just solve this question. Just solve this question. Which property is getting used? This bracket indicates that here is the multiplication sign is hidden and x plus y gives you what? Plus is there. Just simplify using distributive property. It's very easy. It's very easy. Just find the missing term over here. Just go step by step. My dear students, just go step by step. You will be getting your answer. This 3 would be taken along with x. This 3 would be taken along this y. And the plus sign is in between. So that would be 3x. That would be 3y. 3x is already there. So missing term is 3y. Was it easy? So easy it was. Now simplify and classify. Just do it like that. Under root 3 square is what? Whenever square and square root is considered, square root and square is considered, it would be cancelled with each other. Square got cancelled with this under root. So your answer would be 3. That is rational. Second question, under root 49. What is the answer? Under root 49. 7. Yes, that's a perfect square. 7 is rational again. Under root 2 plus 1. Under root 2 plus 1. Under root 2 is your irrational. Irrational adding up to 1 gives you again irrational. Your answer is irrational again. Either you can just do one thing. Under root 2's value, just put 1.414 keeps on going plus 1. That would be your 2.414 keeps on going like that. Isn't it? So that's all for today's class. But before the activity, now it's time for activity. I hope you understood the concept thoroughly. You are pretty much ready for the activity. Can we start it? Let's just rapid fire it. Because we have done the properties in yesterday's session and I have revised all of the questions. I have simplified all of the questions along with you. Now you just need to be very, very quick. Spot the mistake. Is this correct? Under root 7 plus under root 2 gives you under root 9. Ultimately, it is a rational number. Is it so? Spot the mistake. Mistake is there, I'm sure. What is the mistake? Under roots cannot be added directly. They can be added directly when the terms are like. Remember the example of under root 5 plus under root 5? Same things are doubled. Same things are in twice quantity. So you can just take 2 of under root 5. But here the terms are unlike. You can directly add them. You can directly multiply them. Yes, I have just made you write the statement or the result. But here, while adding up to irrational numbers, different quantities cannot give you the result directly. Incorrect, you cannot directly add square roots unless they are like terms. These are unlike terms, you cannot add them. Just under root 7 plus under root 2, this one is just your simplified version. It cannot be simplified further. Yes? Which one is greater? Under root 5 plus under root 2 or under root 6 plus 1? How are you going to do that? I just have told you how to find the square roots by long division method. Yes, it will be taking a bit of time, but you know the method. You can find the answer. Or the other way, you can just memorize the values of under roots directly. At least up to 10, you can memorize under root 2s, under root 3s, under root 5s, under root 7s, under root 6, and then under root 7s, under root 8s, under root 9, we know that is 3. So you can just memorize the values of under roots until 10. Yes. So under root 5's value is 2.24 keeps on going. Under root 2's value is 1.4142135 keeps on going. Sum would be your 3 plus 6, 5 keeps on going. Yes. Now let's just understand the second one, under root 6 plus 1. That would be your under root 6's value is 2.45. Keeps on going, adding up to 1, gives you 3.45. Yes, this is easiest. So which one is greater? Just by looking at them, you can tell directly. Which one is greater? Under root 5 plus under root 2 is greater. Yes, that's how you are going to solve these type of questions. It helped to make your brain logical. One word answer. Just be quick while doing that. Under root 4 is what? Under root 4 is what? 2. Yes, you don't have to think twice. Just say it out. 2. Under root 6 is square. Square root is getting cancelled with square. Doesn't matter what the number you are taking. Just observe square it is present, square is present, get them cancelled. And your answer would be what? And what about the third number? 0 multiplied by under root 17. Will it be under root 17? My smile giving you a hint. No, 0 multiplied by anything gives you 0. Yes, we have solved them. Let's move further. Okay, so it's interesting activity. I'm just showing you 3 statements and you have to choose whether the statement is right always, whether the statement is right sometimes, whether the statement is right never. Means the statement is wrong every time. Okay, are you ready? Let's do one by one. The product of two irrational numbers is rational or not? The product of two irrational numbers is rational always? Think of an example, under root 2 multiplied by under root 2. Two irrational numbers, when multiplied, applying the result, giving you under root 4, ultimately getting you to the rational number. So, the statement is sometimes. Yes, it could be wrong, it could be right sometimes. Now, rational multiplied by irrational will always be irrational. Rational multiplied by irrational will always be irrational. What could you say about that? Can you think of an example just to justify your yes or no? The rational multiplied by irrational gives you irrational. Is it sometimes? Why not always? Think about 0. 0 multiplied by any irrational number will give you 0 again. So how it could be irrational always? Mostly it will be irrational, but not always. Only one example is sufficient just to deny the statement that it is always true. Under root 2 multiplied by under root 2 gives you a, where a is a positive real number. That means we are squaring this under root a. Basically, when a quantity is getting multiplied by itself, we are just taking square of it, giving you a always. When the number is real in higher maths, you will be getting the importance of the statement that a is positive real number. It should be specified. When a is positive real number, then it would be always. Yes? These beautiful statements will be shown up like that, and you have given your answers. That's it. So that was your session for today. I hope you really enjoyed and you have understood the quantities, the distributive properties. You have simplified further the expressions. Yes. So let's just recall once again what are the properties. First one, closure. Second one, commutative. Commutative means order does not matter. Flipping of the order is there, whether it is multiplication, whether it is addition. In case of subtraction and division, it doesn't work. And the third one is associativity, matter of grouping, matter of brackets, A, B, matter of brackets. Yes. and it concludes three numbers. And the fourth one is what? Distributive property. Combination of two operations, multiplication along with the positive, multiplication along with the negatives. I just want you just to open your NCERT and try to solve questions from exercises. Yes, by these beautiful methods I am teaching with you. Now you will be getting these questions solved in a very easy and interesting manner. You have learned how to apply critical thinking, logical thinking. You will be efficient now doing these questions. And whenever you need, just the help of take the help of your teacher present over there. Yes. So now you just can take rest for 1 minute. Just breathe in, breathe out. You can drink water. Then the last 10 minutes will be taken by your